This is definitely one of my favorite probability questions that I've encountered on STEP. Harry, the calculating horse, will do any mathematical problem I set him, providing the answer is 1, 2, 3, or 4. When I set him a problem, he places a hoof on a large grid, basically an infinite grid consisting of unit squares, and his answer is the number of squares partly covered by his hoof. He has circular hooves of radius a quarter unit. So here I've constructed my infinite grid on the left, and I've made it to scale pretty much. So this length is 1, and this length is 1. So you can see I've got a circle of radius a quarter, which means the diameter is a half. I can fit two circles in along the height and along here. So I can fit 4 in if I put them side by side. So Harry could achieve an answer of 1 by simply keeping the circle inside the grid, or in one of the grids like this. If it starts overlapping, then that's going to be an answer of 2. Let's go to 4 next. 4 is going to be something like this. And there is going to be an occasion when he can get 3, where if it just doesn't quite hit one of the other squares. So after many years of collaboration, I suspect that Harry no longer bothers to do the calculations, but just places his hoof in the grid completely at random. I often ask him to divide 4 by 4, which would obviously give an answer of 1, and about a quarter of his answers are correct. If he does 2 plus 2, which would give 4, then about pi over 16 of his answers are right. Is this consistent with my suspicions, i.e., that he's placing them randomly? So we need to work out the probability that obtains a 1 randomly and a 4 randomly. Now we can think about the circle moving around, but as soon as we kind of move up to here, you can also imagine like an equivalent, you can basically combine this and put it here. So we just need to look at one square. So what we're going to be doing is looking at the locus of points of the center of the circle as it moves around a single square. Let's take a look first of all at it being 1 then, because now we just need the circle to stay inside the square. So the highest and most leftward point would be here for the circle. As soon as it moves any more left, then it's overlapping another square. So I've got a distance of a quarter here and a quarter here. And I can move the circle down. This is going to create um, a square actually, because this length is also a quarter. And as we move it around, we get this shape. So if the center is anywhere within this red square, then Harry's going to give an answer of 1. Okay, as soon as the center moves outside, so away from the square, he's going to give it a different answer. So assuming randomness then, the probability, if Harry picks at random, then the probability of him picking a 1 is going to be the area of this square. So it's a half times a half divided by the total area, which is 1 times 1, just 1. And that is going to give a quarter. Which is consistent with him picking it randomly, as we saw that it's consistent with what he's actually doing, because a quarter of his answers are right. Let's take a look now at going over 4 squares. So that would be, for example, here, but also anywhere around here. So I want to kind of move the center, and because I've got this radius of a quarter, it's actually going to end. So if I just fix this for a second, that is like a fixed little area now. Let me actually make it a different color. So if his hoof, the center is here, then obviously it's 4. But as he moves around this circle itself, he's still going to be overlapping all 4. So in fact, this little orange circle that I've made is the area that the center can move around to get an answer of 4. And at this point here, it's just like that's going to be kind of the boundary when it actually hits 3. So all we need to now do is add some more on, like forget about these parts because they're outside the circle. So if the center of the circle ends up in any of these regions, then there will be 4 squares overlapped, and hence Harry will give an answer of 4. So I just need to work out the area of the circle. Probability of 4 is going to be pi times a quarter squared over 1, which is pi over 16. And this again agrees with what has been observed with Harry, and therefore we can say yes, result, I can't remember what the question's actually saying. Harry's answers are consistent with my suspicion that he's picking it randomly. Nice. I decide to investigate further by setting Harry many problems, the answers to which are 1, 2, 3, or 4 with equal frequency. If Harry is placing his hoof at random, find the expected value of his answers. The average turns out to be 2. Should I get a new horse? Okay, let me grab this grid again. So let's work out the probability of picking, I think I'll go with a 2. So to pick 2, we could have the center here, for example, and we could even then move it inwards until the point where it's just like touching. So that will be the edge of boundary. And if I then move it sort of here, you can see I'm going to create an area inside like this. So as long as the center is within this little rectangle, then I'll be overlapping 2. As soon as I go kind of further down from the boundary, I'll be doing more than 2. I could also be moving, okay, so moving across. This would all give 2. So the boundary, as long as I don't hit this little square. So that is the region where Harry would pick 2. This is a quarter, and this is a half. So probability of picking 2 randomly is going to be 4 lots of a quarter times a half divided by 1. Actually, this gives an answer of a half. And finally, for 3. So actually, probably the easiest way to do this is we can rule out this area here and here. So this is not going to give me 3, nor is the very middle bit because that was 1. And then remember, we had the circle being formed for 4. And so actually it's going to be the remaining parts. And we could actually calculate it by calculating 1 square, which is a quarter by a quarter, and then minusing the part of the circle. So it's going to be a quarter squared minus pi times a quarter squared over 4. That would be for just this top right area, for example. And I'll times the whole thing through by 4. I can actually cancel that 4 out, like so. So I'm going to get an answer of 1/4 minus pi over 16. That is for the probability of achieving not 4, a 3. Nice. I think that one is the trickiest one. So let's write down our probability distribution. So random distribution, I don't know what else to call it really. This is the distribution if Harry was to place his foot randomly. Can either pick a 1, 2, 3, or 4 with probability equal to 1/4 and pi over 16. Those were the first two that we found. And then for 2, it was a half. And then here we had 1/4 minus pi over 16. Note, when you sum all of these together, you get 1, so we can be pretty confident about that. We could have worked out this answer just by doing 1 minus all the rest of them, but I think it was quite useful to do it using our geometry argument and then just checking that it all works. So let's find the expected value. That is equal to the sum of xi times pi, from in this case from I equals 1 to 4. So we're going to get 1/4, 1 times 1/4, 1 times 1/4, plus 2 times the half, which is 1, plus 3 lots of 1/4 minus pi over 16, plus 4 lots of pi over 16. That's nice. That comes together to equal 2. Then I'm going to be minusing 3 pi over 16, adding 4 pi over 16. So I'm going to be adding pi over 16. So I get 2 plus pi over 16. We could actually estimate it as a decimal and say that it's going to be 2 plus, well, it's 3 and a bit. So if we just make it 3 and then divide, say, by 15, then we get 1/5. So it's going to be about 2.2. That is the expected value if Harry is just putting his hoop down at random. Now we just need to look at the probability distribution. If frequencies are being picked with equal, sorry, if the numbers are being picked with equal frequency, which is what we had here. So we had equal frequency of picking them. Probability distribution. Okay, so I'm going to get, I call it y now, and then the probability of y. So 1, 2, 3, 4, they're all going to be 1/4. So we're going to times these, we're going to get 1/4 plus a half plus 3/4 plus 1, which gives final answer of 2.5. So we've now got the expected value if picking the numbers with equal chance. We've got the expected value if Harry just puts his foot down randomly. Of course, that's different because his foot is a circle, and we've looked at that. We've done quite a lot of calculations to work that out. And then we're told that Harry's actual answer turns out to be 2. So should I get a new horse? So Harry's average of 2 is closer to the random foot distribution. I don't know what else to call it. Ideally, I got to say, I think it would be better to devise something where Harry's distribution and this distribution differ by more, because they're not that far apart, 2.2 and 2.5. But I think there's still enough evidence if we've done a large enough number of trials. Harry's average of 2 is closer to the random foot distribution. So, yes, you should get a new horse. To do the calculations, that is. Okay, lovely question. Well done.